So a car travels up a hill at 40 kilometers an hour, travels the same distance back down the hill at 60 kilometers an hour. And the question is, what's the car's average speed? And you might be asking yourself, well, isn't it 50 kilometers per hour? And maybe that's your first thought. I mean, if you look at the answer that I give you, it's not 50 kilometers per hour, it's 48. So the question is, why is that? And how do we solve this? So let's start by taking stock of what we know. What we know is that the car drives up, what can I put this, up the hill and then back down, right? So one good way to organize your solutions is to write out your variables. There's a certain distance it goes up the hill, it takes amount of time, and there's the velocity or speed up. Delta x, delta t, and v down, right? Okay, so we don't know anything here. We do know this, and we know this. We know that up the hill it goes 40 kilometers per hour. We know down the hill it's 60 kilometers per hour. And that's all we know. And somehow we have to figure out what its average speed is for the whole trip. If you think about VAV, and this is speed. Remember, we've got, this is speed without the vector sign. It's V stands for speed. VAV is the total, let me just say it in words actually, is distance, total distance, or distance traveled, divided by the time taken, right? So what is the distance and what is the time? We don't know the answers to those. So what we have to do is make some sort of suppositions. There's two ways to answer a question when you don't know how far it is. But what you end up doing often, and this is a trick that you're going to use again and again, is to call the distance a variable. And we're going to call it, say, d for distance. So the distance it traveled up, we don't know, but we know it's d. And we know that it traveled the same distance down. So we know the relationship between these three variables is related with this equation, v equals delta x over delta t, right? So what we're going to do is rearrange this equation and solve it for t. So in the case of the up, we're going to say delta t equals delta x over v. And in the up, so I'm only looking at the up information, it traveled a distance d, and it went at a speed of 40 kilometers an hour. So delta t up is d over 40. So I have an expression for the time it takes to go up. And I can do the same thing over here for down. Delta t equals delta x over v. In this case, delta t equals d, same distance up and down, but now I'm going faster. I'm going 60. So I've got these two expressions for up and for down, right? And I'm going to use those when I go back over to this section to look at the actual average velocity. So the total distance, well, the distance up is d and the distance down is d. So it's d plus d. Then I'm going to divide it by the time it took. Well, the time it took to go up is d over 40. And the time it took to go down is d over 60. So I've got kind of a complicated equation, but definitely solvable. I'll just slide this up a little. And we can see that to simplify this, I'm going to get 2d in the numerator. And in the denominator, I've got a fraction. I can find a common denominator. So 60d plus 40d. I'm just multiplying this by 60 and then divided by, and then I'll multiply them together, 40 times 60 on the denominator. Then I'm just going to invert and multiply, right? Just solving fractions now, which equals 2d times, so then it will be times 40 times 60 divided by, now what's 60 plus 40d is 100d. I hope you can see right off the bat that, my, where did I go? That my distances cancel out. Oh, I keep touching that. So this distance cancels this distance or that D cancels that D. And so now I can solve this out. So 2 times 40 times 60 divided by 100. I think you'll see it works out to 48 kilometers per hour. And that's my average speed. So it's less than 50. The thing that you have to know about speed is time-weighted average. Weighted average. So what that means is, since you spend longer traveling up, at 40 kilometers an hour to go a certain distance takes longer than the same distance at 60 kilometers an hour. So you spend more time traveling 40 kilometers an hour up the hill than you do coming down the hill. And so that 40 factors more heavily into the average. So that's why your answer 48 is sort of skewed to the lower end rather than the upper end.